This video is the first of a four-part series working through sequences for Algebra 1. So before I get to what a sequence is, let's start with the problem. So here I have a picture and I have a series of dogs because, well, who doesn't like to talk about dogs? So if I'm looking at these dogs, what's the pattern we notice? Well, I have one dog, and then I have three dogs, and then I have five dogs, and then I have seven dogs, which could be pretty great depending on where you live, or seven dogs may be a little much. But if I'm looking at these dogs, what's the pattern? Well, I'm going from 1 to 3, 3 to 5, 5 to 7, and I can see that, well, I'm adding 2. I add 2 dogs every picture. So that'd be kind of fun, just getting 2 dogs every day. So that's it. We're just looking for what's the pattern. Now, if this pattern were to continue, how many dogs would be in the next 3 pictures? Okay, so I have 7 to start with. So if I take 7 and add 2, I'm up to 9 dogs. Got 9 dogs. And then I add 2 to that, I've got 11 dogs. Add 2 to that, I've got 13 dogs. That's how many we're going to have. And how do I know? Because the pattern is +2. I'm adding 2 every time. So this idea may seem very simple. We're just adding 2 between each picture, and that's what we're going for. This should be relatively straightforward, but this idea of following a pattern and a series of terms is what is referred to as a sequence. So let's define that. So a sequence is an ordered list of objects, in particular numbers. You could do like squares, circles, triangles, something like that, but we're going to try to keep it specifically numbers. And these numbers follow a pattern. Now, sometimes the pattern is really obvious, like we just saw with the dogs. We were adding 2 every time. But sometimes the pattern may get a little bit tricky. So that's where we're going to have to use a little thought. Now, for this one, one thing you need to know is that each part or each object is called a term. So when I'm looking here, this is a term. So 1 is a term, 4 is a term, 9 is a term, 16, and 25. So those are referred to as terms. So they're separated by the comma. Now with sequences, there's a lot you can go into, but we're going to focus on finite, infinite, and we have one other term we're going to look at. Now this word finite basically means limited, meaning that there's only a certain number of terms. So here I have 1, 4, 9, 16, 25. This is a finite sequence, whereas an infinite means it goes forever. So here I have 1, 2, 4, 7, 11, and this ... is what tells you that it's an infinite sequence. So if you see just those ... dots right at the end, that means the pattern is going to keep going ad infinitum, or forever. So here I've got some sequences, and I want to determine the next 4 terms. We're going to try and look for a pattern and see what we come up with. So for this first one, let's go from 2 to 8. Now, kind of a rule of thumb, we're going to write this out. So what I like to test, the first thing I like to test is adding or subtracting. That's what I like to test first because that tends to be easier. So I'm going to see if I add or subtract between my terms to get what I want. So let's see, 2 to 8, let's try +6. And then let's see, is 8 plus 6, 14? Yep. And then is 14 plus 6 equal 20? Yeah. So I found my pattern, +6. So I'm going to try adding first, which worked. So my next term would be 26. I would have 32, 38, and 44. So I'm adding 6 every time, and there's my next 4 terms. Let's try the next one. So over here, I go from 0.5 to 1. So if I'm trying adding first, I add 0.5. Now, if I go to add again, well, 0.5 plus 1 is not 2. So adding does not work. So if adding and subtracting doesn't work, my next tip is to try multiply or divide. So try multiplying or dividing. That's my second tip. Now, there are other things you can do besides multiplying, dividing, adding, and subtracting, but again, this is for Algebra 1. We're not going to get too intense. Let's try multiplying. So 0.5 is the same thing as 1/2. So 1/2 times 2 equals 1. So then here again, 1 times 2 equals 2, great. And then times 2 equals 4. So there's my pattern. So if I keep going, my next numbers are 8, 16, 32, and 64. I'm just multiplying by 2. Let's try this next one. So for this next one, I'm going from -3 to 9. Well, that would be a plus 12. All right, now if I add 12, does that take me to -27? No, that does not work. So adding or subtracting doesn't work here. I'm going to try multiplying. So let's see, 3 times what, or -3 times what is 9? So that would be times -3. And then 9 times what is -27? Well, times -3. So I see here that I'm actually multiplying by a negative. But just a little tip, if you ever see these alternating signs like negative, positive, that means you're multiplying by a negative. So my next number would be -243. And let's see what my next one would be. We've got times -3, so it's going to be positive. I think that would be 729. And then times 3 would be, times -3 would -2,187. And multiply again by -3, we get 6,561. Lovely. So for the next one, let's see here. So let's try adding and subtracting. And so this, for subtracting, we'd have minus 2.5. Okay, so then if I subtract 2.5, does that continue the pattern? And it does. So I see here I'm subtracting. So my next term would be 0, -2.5, -5, and -7.5. So I'm subtracting 2.5 from each term. And there we go. That's how we identify our patterns. So let's continue with that. So what we're going to look at specifically is this thing called an arithmetic sequence. Now it looks like the word arithmetic, but how we say it is arithmetic. It sounds a little weird, but a sequence is arithmetic when we add the same thing to get from one term to the next. Add, and I'm going to also write subtract, because this tends to mess people up, because adding -4 is the same thing as subtracting 4. So this counts as adding. So adding or subtracting the same term to get from one term to the next. So adding and subtracting the same thing. So for here, I'm looking at this one, what am I doing? Well, I'm adding 4. So plus 4, plus 4, plus 4, plus 4. Now this 4 has a name. And this is what is referred to as the common difference. Now we're going to use this letter D to represent the common difference. So it's what we're adding or subtracting to get from one term to the next. I'm going to write subtract. So it's what you're adding or subtracting to get from one term to the next. Now you could be wondering, why is it called the common difference instead of the common sum? Great question. What is 5 minus 1? The bigger term minus the smallest. Well, it's 4. What is 9 minus 5? It's 4. 13 minus 9, it's 4. 17 minus 13, it's 4. That's why it's called the common difference, because if you take the bigger term subtracted by the term in front of it, then you will get that same number every single time. So that's why it's called the common difference instead of the common sum. So we can identify which of these are arithmetic. Now we actually already did this, so we're not going to do too much with it. So for this one, we noticed we were adding 6. So since I'm adding 6, this is arithmetic. And what were we adding? We're adding 6. So there's my common difference. For this one, we weren't adding, we're multiplying. So this is not arithmetic. Since I was multiplying, it's not arithmetic. There's another term for that, but I'll get to it in a later video. And for this one, I was multiplying by a negative. So it is not arithmetic. I was not adding or subtracting. And the last one, I'm subtracting. So I'm subtracting 2.5 or adding -2.5, depending on how you want to say it. So this is arithmetic. And my common difference, D, what am I adding? Well, I'm adding -2.5. So I'm making it go down. Now we have one last bit of notation to look at, and then we'll wrap it up. So when we're looking at a sequence, we have this function notation, f of n. Now, if you're watching this video and you have a math background, you may be thinking, well, why aren't you using a sub n? That's because we just finished a function unit, so we're sticking with function notation. So you could use this thing a sub n or f of m. And what that does is it tells me the nth term in the sequence. Now this sounds really weird, but let me explain what it means. So nth, what it means is it tells me that number in the sequence. So if I want to find the first term in the sequence, I would plug in f of 1. That would tell me the first number in the sequence, which in this case, the first number is 1. Now, if I'm looking at f of 2, it wants me to know what is the second term in the sequence. What is the second term? Well, that is 4. Oh, 4. There we go. That is 4. Next, if I'm looking at f of 3, that's asking me what is the third term in the sequence. Well, the third term is 9. Okay, so my second term, my third term. If I do f of 4, what's the fourth term? 16. And then f of 5, what is the fifth term? It's 25. That's all it's asking me for. When I'm asking to find what is f of 4, f of 1, it's just what is that term in the sequence. Now with this notation, we can actually come up with rules to describe our sequences. So we have these formulas, and we're going to use these formulas to find the first 4 terms in the sequence. So here's how this works. If I want to find the first 4 terms, what numbers would I plug in? Well, I would plug in 1, 2, 3, and 4. So to find my first term, I would do f of 1. So I would replace n with 1, so 4 times 1 plus 1 equals 5. Okay, to find my second term, I would do 4 times 2 plus 1. So 4 times 2 is 8, plus 1 is 9. And I would keep going. To find my third term, I would plug in f of 3, plug in 3, plus 1 equals 13. And then the last one, 4 times 4 plus 1 equals, let's see, 16, 17. And there we go. Now this particular function is arithmetic. I see here that I'm adding 4 every single time. And hint, hint, there's a 4 up here. That's going to be important later. Let's try this one and we're done. So to find the first term, we're going to plug in a 1. So 2 to the first power. So that would be 2 times itself, which is 2. The second term, f of 2, we would do 2 to the second power. So 2 squared is 4. Next, we would do f of 3. So 2 to the third. So that would be 8. And then f of 4, so that would be 2 to the fourth, which is 16. So my first 4 terms are 2, 4, 8, and 16. So I know that was a lot, but that is kind of the beginning of sequences. In the next 3 videos, we're going to be diving a little bit deeper into arithmetic sequences. We're going to look at graphing, and we're going to look at how do we come up with these formulas that we just worked with. Stay tuned.